Hello friends, my name is Baji. Welcome to our channel. This is episode number 13 in our performance testing must-have skill series. In this video, we will continue to discuss the remaining performance testing core concepts. If you are watching this series for the first time, please watch previous episodes of this series and continue these concepts. You can find the link to this playlist series in the description. We will begin by discussing the topics covered in this video. First, we will explore various types of performance metrics. Then, we will understand the difference between performance testing versus performance engineering. Next, we will dive into Little's Law, a crucial concept in performance testing. Finally, we will conclude this video by exploring some common terminologies in the field of performance testing. So, without wasting any more time, let's jump into this video. Let's start with the topic of performance metrics types. Before we jump into the topic, let's quickly try to understand the concept of a metric. Basically, a metric is a quantitative measure used to validate various aspects of an application's performance. These metrics provide specific data points that help testers and developers understand how the system behaves under different conditions. There are two types of metrics reported in every performance testing: application health metrics and server health metrics. As you know, application or software will be deployed onto a server. So, we will report the application health metrics as well as server health metrics. Let's explore some of the examples of application health metrics. The application health metrics measure the application performance during the performance test. Some of the metrics are response time. This is the time taken by the system to respond to a user request. Throughput, the number of transactions processed by the system per unit of time. Error rate, the rate at which the application transactions are failing. These are just a few metrics, and there are many more metrics that will help us to validate the application performance. This kind of application health metrics will be reported by performance testing tools. There are so many tools available in the market, and the team selects a specific one based on client's requirements and application compatibility. Popular ones are like LoadRunner, JMeter, NeoLoad, etc. In this series, I will be covering JMeter concepts as part of module number 6. Next one, server health metrics. These metrics measure the server resource health during performance tests. For example, CPU utilization, memory utilization, disk utilization, etc. Here, utilization is expressed in the percent of the system resource used during the test, like 40%, 50%, etc. It helps in pinpointing potential resource related problems. This kind of server health metrics will be reported by performance monitoring tools. In the past, these metrics are integrated with performance testing tools. However, these days, we have separate monitoring tools available to monitor and report these metrics. Popular tools are like Dynatrace, AppDynamics, Neuralink, Datadog, etc. Next, let's try to understand the difference between performance testing and performance engineering. Basically, performance testing is a subset of performance engineering. Performance testing and performance engineering are closely related, but there are a few key differences between them. Before exploring the difference, let's look at a real-time example. When you visit a hospital, doctors often recommend various medical tests like blood tests, x-rays, and many more. So, you go to the lab and then request the lab technician to conduct the prescribed test and provide you with the report. The lab technician will carry out all the tests and provide his observation in the form of a report, isn't it? Here, we can correlate the lab technician with the performance tester, as performance testers will also conduct tests and provide the reports. Following that, the doctor will review the reports and offer recommendations for addressing the medical problems. Similarly, the performance engineer will review the results from the performance tester and provide his recommendations to optimize the application performance. For example, a performance tester looks for the response time during the load test and directs the development or infrastructure teams to optimize it. On the other hand, a performance engineer analyzes why and how the response time has a certain value. Then he tries to find the solution that can be used as a guide by the development team to build a performance optimized application. So, performance testing usually deals with identifying the issues in the application during the performance test, whereas performance engineering not only deals with identifying the issues but also eliminate them to build a performance optimized application. Based on the organization and team size, we may have separate resources for performance testing and engineering. In some organizations, the same resource will do both activities. Next, let's dive into the topic of Little's Law. This is one of the important topics in performance testing. Little's Law is a fundamental theorem in queuing theory, a branch of mathematics that deals with study of queues. The law is named after John D.C. Little, who was a professor at MIT. This law was formally published in 1961. You can also use Little's Law in any situation wherever there is a queue, whether it's the number of people in line at the grocery store or tasks executed by software. Little's Law states that the average number of items within a system equals the average arrival rate of items into and out of the system multiplied by the average amount of time an item spends in the system. Mathematically, Little's Law is represented as L equal to lambda multiplied by W, where L equal to average number of customers in a system, lambda equal to average items arrival rate, and W equal to average time a customer spends in the system. Let's look at a real scenario where we can apply this law to find out the answers of a business owner. Let's say you own a coffee shop. You want to know the average number of customers you will have in your shop at any given time to ensure you have enough employees to handle business and the room in your shop to serve them. system. Let's assume that you have about 20 customers arriving every hour. It takes each customer an average time of about 15 minutes, equivalent to 0.25 hours, to order, pay, and leave with their coffee. Next, apply these numbers in the formula. So the formula is L equal to lambda multiplied by W. Here, people arriving at the store per hour, that is 20. So lambda equal to 20. The average time spent is 15 minutes. Since the users are considered per hour, we should convert these minutes into hours. So W equal to 0.25. Now we have lambda and W. Let's substitute these values in the formula. So 20 multiplied by 0.25, which is 5. So L equal to 5. That means on an average, there will be 5 customers in the store at any time. Hope you understand it. Let's explore the various benefits that customers can gain by applying this law to their requirements. Improved efficiency. By utilizing this formula in the queuing system, we can allocate resources more efficiently and reduce wait times. Better customer service. Little's Law can help to predict wait times and provide better customer service. This will keep customers satisfied and increase loyalty towards your organization. Improved resource utilization. With the help of law, we will be able to better utilize our resources and staff. In performance testing, we will slightly change the terms, and the formula is n equal to x multiplied by z, where n equal to average number of users in a system, x equal to throughput measured as a TPS, nothing but transactions per second, z equal to execution time, which includes response time, think time, and pacing. Don't worry if you don't know anything about response time, think time, and pacing. I will be covering them in the next topic. I'm also sharing a blog post in the description where this law is explained in more details with some examples. Next, we will look at the different purposes of this law in performance testing. We will use this law to validate the performance test results to understand if there are any issues with the load simulations. For instance, are we simulating the correct number of virtual users to target the desired throughput? Workload modeling is an important factor in performance testing. It should reflect the end user pattern, so we cannot simply plan the test with a random number of users. Understanding Little's Law is crucial for performance testers as it provides insights into the relationship between system utilization, response time, and the number of concurrent users. It helps in capacity planning, performance optimization, and predicting system behavior under different loads. The Dynatrace product team has also published an article about Little's Law which explains about how we can use this Little's Law to plan the capacity, and I'll share the link in the description. I hope you understand this concept. If anything is not clear, please feel free to mention it in the comment section. Finally, let's explore some of the common terminologies in performance testing. In this video, I will be explaining some of the common terminologies frequently used in day-to-day performance testing tasks. First one on our list is virtual users. I have already explained it while discussing performance testing types. Let's quickly recap. Executing the load test with real users is not feasible for several reasons. That's why the teams will use different load testing tools to create the users to simulate the real user behavior. Since these are not real users, they are referred to as virtual users. Some people also call them V users. As they are not real users, someone needs to provide them with the instructions to test the different business use cases. So performance testers will develop these instructions in the form of a script using different load testing tools like LoadRunner, JMeter. Next one on our list is simultaneous users. Simultaneous users will execute the same activity at the same time. For example, if we are testing the login use case with 1000 users, so all the 1000 users will log in at the same time. So all 1000 users are referred to as simultaneous users. Next one, concurrent users. Concurrent users are active in the system. However, they will not test the same activity at the same time. Some users may test the login use case and others may test account summary, etc. Some interviewers may ask about the difference between simultaneous users and concurrent users. So simultaneous users perform the same activity at the same time, whereas concurrent users will perform different activities. Next one on our list is think time. In real time, no one will continuously do the transaction one after another, isn't it? Here, transaction is nothing but a user action in the system. For example, on the Amazon site, you are looking for some performance testing books. After you search, you may take some time to review the list and click on the specific book, right? So the time you are taking from the moment search results shows up and clicking a specific book in the list is called think time. In simple words, think time can be defined as a time gap between two transactions. Next one on our list is iteration. Iteration in performance testing refers to a single execution of different transactions in the business use case from beginning to end. For example, we are testing the transfer funds use case. To test this use case, the user needs to execute different transactions, right? Like I said, transaction is nothing but a user action. So in transfer funds use case, we have different user actions like user has to launch the application is a transaction, and then he has to log in with his credentials is another transaction, and then the user needs to load the transfer transfer funds page. That is one more transaction. And then he has to select the from account and to account and input the amount. And finally, he needs to click the transfer button. So that is another transaction. And finally, the user needs to log out from the application. So that is another transaction. So we have total 5 transactions and we need to execute them. That means a single execution of all these 5 transactions is called an iteration. Next one on our list is pacing. In performance test executions, we always execute multiple iterations. Between iterations, we always keep some wait time to simulate the real user behavior. Because in real scenarios, users will take pauses between transactions or iterations, right? So the pacing is a time gap between 2 iterations. Next one on our list is response time. When user sends a request to the server will take time to review the request and process it. So response time is the entire duration from when a request leaves the user's computer, travels to the server, undergoes processing, and returns with the response to the client. Since it is measured for a transaction, we can also call it as transaction response time. Next one on our list is hits. Hits refers to the number of requests or transactions made to the server within a specified period. Each time user interacts with the application, such as clicking a button, submitting a form, or requesting a web page, it generates a hit. For example, if a performance test simulates 1000 users accessing a website and each user requests 5 pages, the total number of hits would be 5000, right? Like 1000 users multiplied by 5 pages. Next one on our list is throughput. Throughput is a crucial metric that measures the rate at which a system can process a specific number of requests or transactions within a given time frame. It is often measured as transactions per second, nothing but TPS. Higher throughput indicates that the system can handle a larger volume of user interactions, indicating better performance. Throughput is influenced by various factors such as server capacity, network speed, application architecture, and the efficiency of the code and database queries. Next one on our list is bottleneck. So what is a bottleneck? A bottleneck refers to a point in the system where its performance is significantly degraded. In this situation, the performance SLAs of the system are not being met. Performance testers aim to pinpoint these bottlenecks through various testing techniques such as load testing and stress testing, etc. These bottlenecks can be classified into 2 categories: software bottlenecks and hardware bottlenecks. Let's look at each type of bottleneck in detail. A software bottleneck refers to application code level issues that impacts the application's performance. For example, memory leaks generally happen due to poor memory management techniques. Another example is high transaction response times. All these software bottlenecks can be addressed using profiling techniques. We should understand that adding additional hardware resources will not help address the software bottlenecks. A hardware bottleneck refers to the server hardware resource issues that impacts the application performance. For example, high CPU utilizations and memory utilizations, etc. During the performance test, monitoring hardware resources can help to identify such resource-related issues. If the issue is related to hardware capacity, adding additional hardwares may address the bottleneck. So that's it for this video. Thank you so much for staying till the end and supporting me. I hope you understand all the concepts in this video. In case any specific concept is not clear or requires more detailed information, please feel free to mention it in the comments section. All the video notes have been uploaded in GitHub and you can find the link in the description. If you are new to our channel, please consider subscribing and also like and share this video so that others will also get benefited. With this video, we have completed all the planned concepts for module number 4. In the next video, we'll go through some of the commonly asked interview questions from performance testing core concepts. So I'll see you in the next video. Until then, take care, stay safe and keep learning.